All right, and we'll get started. Hi, everyone, and thanks for joining today. My name is Janine West. I am the Grower Technical Analyst for Landscape Ontario and the project manager for our LOLA project. That's our labor assessment study, and that's funded by Ontario Ministry of Agriculture, Food and Rural Affairs. We will be recording today's webinar, and it will be available for public viewing on our website and LO's YouTube channel. So technically, a couple of things. Again, if you have any issues with audio or video, please send us a note in the chat. Everyone that's attending is muted, and but we do have a couple of other ways that you can communicate with us. Again, we've got the chat, and if you have particular questions for our guest speaker or myself, please put them into the Q&A option. If you hover over the bottom of the screen, the Zoom screen, you'll see a bar there that you can raise your hand. You can go into a question and answer section. So for today, we're working on our webinars focusing on lean management. So lean management approaches focus on eliminating waste, minimizing movement and distances with a continual improvement mindset. The principles behind lean management are relevant to all farms. So this is our first, and actually it's now a 3-part series. We are going to introduce you to Gary Cortez of FlowVision. So Gary leads us through the background and some of the projects they work on throughout North America and globally with the green sector. Many of you have heard of Gary. He's worked closely with a number of nurseries in Canada. So Gary, I'm happy to switch it over to you and you can share your screen.
Perfect. Can you guys hear me?
Yep, I can. Hopefully, if you can't, just make a note in the chat, please.
Okay, well, good afternoon. Thanks for attending. What I want to talk to you about is a concept called lean flow and how it could be implemented in your facilities. And I want to show you some of the work that we've done at other growers in Canada and North America, and how how these techniques can help you improve labor, which I know in Canada is just as a big issue as it is here in the US. So the topics we want to talk about is lean in the green industry, or lean flow. Lean flow really comes from the Henry Ford assembly line concepts. The reason why we call it lean flow is we have two approaches that we want to achieve, or two goals that we want to achieve. One is we want to lean out the process, take out the waste, all that non-value added work that we do. And once we lean out the process, what we want to do is we want to get the product to flow. So leaning out the process, getting the product to flow, and then talking about labor issues, which again is a worldwide issue with growers and in other industries as well. And some of the techniques that we've successfully implemented to help improve productivity efficiency. One is a technique we call progressive work. And again, progressive work dates back to the Henry Ford assembly lines, and I'll show you how that actually works and how you can set up your processes to be more efficient. The other technique that we've talked about and implemented quite a bit with our customers is what we call a dock shipping supermarket. And the shipping supermarket is a technique where we bring product up into the loading dock and then we shop it from that supermarket. I'll explain to you how that works and show you a video from one of our customers, Van Belle Nursery out in Abbotsford, British Columbia, who's successfully implemented this. And the other thing is transportation costs, are they going up? And the answer is yes. So in order to reduce our transportation costs, how can we reduce that? One is by, if you're shipping your products on racks, optimizing that rack, basically having as little air on that rack as possible. And then when you're loading the trucks, have as much payload, as we call it, on that truck. So you get the most payload out of the truck, the least amount of air, reducing your transportation costs. So lean, again, what we want to do is we want to lean out the process. We want to take the waste out of the process, eliminate the waste, eliminate stuff that we call non-value added work. Non-value-added work is work that we do that doesn't add any value to the product, but what it does do is it increases the cost of the product. Where value-added work, what that does is it increases the worth of the product. So our focus is let's eliminate that non-value-added work, or in lean, we call it waste. So once we lean out the process, what we want to do is get the product to flow. So we want to make that product flow, eliminating any bottlenecks that we have in the process. So balancing out the processes to make sure that the product is flowing at a particular rate. Now, when we talk about the term bottleneck, it comes from looking at a bottle. If you take a look at a bottle, when you're flowing product through the body of the bottle, you have a big volume going through, but once you get to the neck of that bottle, you restrict its flow. So what happens is we're creating a bottleneck, and this is true in any industry. So when you're producing product, what you want to do is you want to have a constant, steady flow of pipeline, the product flowing from beginning to end. You want to avoid any bottlenecks. With lean flow, when a process is designed, we're designing out all of the bottlenecks from beginning all the way through the end. Now, lean flow is a business strategy, and what I mean by that is, as an example, if we're implementing in your shipping area, we're not just going to go and take a look at, okay, what can we do to better pick the product or better pull the product? What we want to do is take a look at, okay, from when I receive the order in the office, what happens to that paperwork? How does that paperwork get translated into another piece of paperwork that tells us what to pull, when to pull it, how many to pull, and then all the way to getting that product onto a truck. So it just doesn't impact the physical area that we're changing, it impacts the office processes too. Now we have to change maybe the cutoff time. Maybe we have to change how, when I receive an order, how quickly can I respond to that order? So the other thing about lean, again, it's a business strategy. It's not just impacting the floor, that one area that we're looking at. It impacts processes upstream and downstream from there. And then the other thing too is with lean, everything is math-based. So it's not someone's opinion on how we should design the process. It's based on math. So being based on math, we can apply it to any industry, any product. And back in 2003 is when we first started working in this industry. We started our company back in 1998, and we were working with all types of manufacturing companies. And when we first started working in our first nursery, and even now when we work with growers, they always say, yeah, we don't build computers, we don't build tractors and stuff like that. But to us, it's just a widget. You guys are growing a plant. We apply the same math, we apply the same implementation strategy for plants, trees, shrubs, annuals, perennials, what have you, regardless of what the product is. Why? Because it's based on math. And then the other thing with lean too is it's something, we have something we call rapid time to value. And what rapid time to value means is you don't have to wait 2, 3, 4, 5 years to get your payback. Unlike when you buy a piece of equipment, it's a 5-year payback is good, 7 is all right. With lean, typically within the first season of running your process, you get your benefits back, or within the first year of running the process. Some of the industries that we've worked in, again, it's all based on math. So it doesn't matter if it's a pair of shoes, if it's the US Mint, a John Deere tractor, or growing orchids, the process is still the same. Some of the companies that we've worked with, a couple of highlight here, Jolly Farmer, we've done a bunch of work with Jolly Farmer out in New Brunswick, Canada, really good company, really good practitioner of lean. They got really good benefits. Another company that you're going to see a video of that we've been working with since 2004 is Van Belle Nursery. So again, just a couple. We've done work with several growers in Canada, but just a few that are really good lean practitioners. So as we talk about the labor issues, the question is, are you having difficulty getting employees? And when you do get employees, do you have difficulties getting good employees? I know a lot of our customers down here in the States, when they have to hire their local employees, it becomes an issue because they're not the best employees, but they can do the work, maybe not as efficiently as other people that they can hire. So I can get the employees, but they're not always the best. And with the labor cost rising in a lot of the states here in the US, the labor is going to go up to $15 an hour. As an example, in California, I think in 2022, the wage is going to be, the minimum wage is $15 an hour. And if you include overtime in there, they're paying $22.50 an hour. So it gets really expensive. And in a lot of the companies, I would imagine you guys are probably the same, the margins are not super high. So every time we increase our cost and we can't reduce it somewhere else, it just diminishes the margins and the profitability of the company. So the question is, are foreign workers the answer? The H-2A program here in the US works really well, really good employees. They come in to work and they really work their tails off. And the same thing in Canada. As an example, Van Belle Nursery, they use a lot of foreign workers and they do a really good job, and the majority of them come back year after year. But even with the foreign workers, we still need to look at how can I reduce my labor, increase my productivity, increase my efficiency. So how about improving your process to improve your productivity? And basically what we're talking about is increasing the output with the same number of people. And lean flow is the solution. And one of the things you're going to see about our solution is we're not big on spending a whole lot of money on equipment. So we want to use the equipment that you have. Again, equipment takes a long time to pay back. The equipment that you typically buy, you only use for a portion of the year, maybe 6 months, 3 months, 4 months, 5 months during the spring, and then it sits idle for the rest of the year. So when we can minimize any capital expenditure, that's what we'd like to do. So the next 3 slides that I'm going to present is basically the concept that we want to implement across your nursery, across your greenhouse. Again, it doesn't really matter the processes. Here we have 3 processes: labeling, flat filling, and sowing. It could be labeling, flat filling, and sticking, or labeling, pot filling, and transplanting. Whatever the process name is, it really doesn't matter. But this is the way the concept works. And for some of you, this may be true. What I'm going to explain, for others, it may be the way you used to do it. So typically what happens is, if I have a process where I'm applying a label to the tray, the way it normally works is you get an order to produce X number of trays. In this example, the work order says, I want to produce 50 of these trays for this variety. So what normally happens is they grab the trays, they have their roll of labels, they take the first label and they apply that label to the tray. Now let's assume that in each of these processes, it takes a minute to do the work, to keep the math really simple. So they take the first tray, they apply the label, they take that tray, they set it aside. So we technically did what we would refer to as 1 minute's worth of value added work. Now we completed that tray, we set it aside, I grab the next tray, I apply another label to it, I take that tray and I set it on top of the first tray. So what happens is that first tray got completed in 1 minute. Since the order is for 50, that tray has to sit for another 49 minutes before it can move on to the flat filling station. So once we complete the 50th tray, it then goes to the flat filler. And this is another very common process that we see. I run the first tray through the flat filler. Let's say it takes a minute to fill up that tray. I take that tray, I put it on a rack, I put it on a wagon. So I completed 1 tray in 1 minute of value-added work. It's going to sit there for, again, another 49 minutes until the 50th tray is completed. And then the same thing happens in the sewing process. The first one's completed in a minute. It waits for the other 49 before we take it, in this example, to a germination chamber. So now the first order of 50 went through the process and it was completed in 150 minutes. If we take a look at the inventory that we have, 50 here, the next order called for 50, the third order called for 175. So our total inventory that we have in process is 275 units, 275 trays, and the order for 50 again took 150 minutes. Now, this is the way it should work if everything runs as it should. But as we know, sometimes things happen in the process. So instead of taking 150 minutes, it may take longer. So now my lead time, that 150 minutes is what we call lead time. That lead time now, let's say, is 550 minutes. So the longer my lead time, the more inventory I'm going to have in the process. It's kind of like the chicken and the egg. Is it because I have a long lead time that I have a lot of inventory, or is it because I have a lot of inventory that I have a long lead time? Nevertheless, what we want to try to do is reduce this time, this lead time, and make it as short as possible. So as we talked about before, we want to be able to flow our products. So what we're going to do in Lean, we're going to set up what we call a flow line. And in this flow line, we're going to set it up where we have what we call operations or workstations. They're synonymous. So we have operation 10, 20, and 30. And within these lines, we're going to have this visual signal on the table, on the ground, depending on the process that we're designing. And this is called an in-process Kanban. Kanban is a Japanese word that means a signal. So this is what we call an in-process signal. So we'll mark the table, the conveyor with an IPK. What the IPK is going to be used for is two things. One is when it's empty, it's the employee's goal to fill that in-process Kanban up. So they're going to do the work and they're going to place it in the in-process Kanban. Their goal is to keep that in-process Kanban wet or keep it full. So if you have one IPK, you put one tray in there. The other reason for the IPK is to help us balance the line. Again, in some cases, because we have an imbalance between these two operations, we'll put more than one in-process Kanban in between. So the focus of Lean, again, is to eliminate the waste, not to focus on, hey, it takes a minute to do the work. How can I take it down to 30 seconds, 45 seconds? We'll focus on that later through continuous improvement. Initially, what we want to do is get the waste out of the process. Where was the waste? The waste was all that inventory that was building up in between the operations. So in this case, they grab the tray, they apply the label, they place it in the IPK. A minute later, it then goes through the flat filler. A minute later, comes out of the flat filler and goes through the sewing line. So the first piece, the first tray out of the order of 50 came out in 3 minutes. So what we did was we wet the line. So now we have a wet line. Having a wet line means I have inventory in the process. Now with my line wet, and if it takes a minute to do the work in each of the operations, every minute I should see a product flow off of the end of the line. So that means the first one came out in 3 minutes. The next 49 should come out in 49 minutes. So my order of 50 now came out in 52 minutes. So my lead time is now 52 minutes compared to the first slide that I showed you, which was 150 minutes. But we didn't reduce the labor time. So how am I going to get the productivity improvements? Again, the productivity improvements initially, we're going to get through the elimination of the waste. So now instead of having 50, 100, or 75 pieces in between the operations or the stations, I only have one. So because I have less inventory in the process, my lead time is shorter. And since I have less inventory in the process, what happens is my lines are shorter. My lines are smaller. So what does that mean? I can get more production out in the same square footage, in the same footprint, than if I were to do it in a traditional way. So with Lean, based on these concepts, I have a shorter lead time, quicker throughput. I have less inventory. Having less inventory means I don't need as much space, so I can get more production out in the same footprint. So those are some of the advantages that we get just by setting up the process as described. Now, when we implement Lean, again, we follow a specific path. We go through certain steps, regardless of what the product is. So we have 3 phases. The first phase is what we're going to do is we're going to take and collect data. We're going to go and gather data. And then after we gather the data, we're going to do some calculations and we're going to do some analysis. And then once we've done the analysis, once we've done the calculations, then we're going to go and we're going to do the layout. We're going to do the design. We never designed a process before we do the calculations, and we never do the calculations until we get the data. So again, the first thing that we're going to do is we're going to start gathering data. So the first thing that we'll do is we will create what we call a process flow chart. This process flow chart is an example from Van Belle Nursery. And this process flow chart shows where we begin the process. This is for a 4-inch liner. So it starts at taking the cuttings. We take the cuttings, we prep them, we bring them over to the production line, and then we load the flats onto the flat filler. It gets filled, it goes through the watering tunnel, it gets stibbled, and this is where we do the potting, where we do the sticking, and then all the way through until we get to the shipping end of it, where we make a box, we put the pots in a box. Some of them will get bagged. Once we box them, we then palletize them, and then we ship them. So this is a very long process, 12 to 18 months from start to finish. Again, we're taking what we call the holistic approach, that business strategy, where we go from the beginning all the way through the end. We're not just picking, okay, how can I pack it quicker? We're looking at the entire process from the beginning all the way through the end. Another example of a process flow is for geraniums. And in this example, it's a simpler process flow where we're receiving the cuttings from the houses. They go through a pre-cooling process, they get cleaned. There's a process that they call incomplete when we don't have enough of that cutting. And then it goes through it gets put in the bag, it gets sealed. And then this distribution really is a supermarket rack where we put the cuttings away. And then we go shop it. And as we're shopping it, we're making a box one at a time. One of the key principles in lean is, again, a steady flow of product. One of the biggest issues that we see in this industry is companies like to build ahead. This company had a sister facility that we worked with in Costa Rica, and they used to build their boxes a week in advance. Now, a week of boxes takes up a lot of space, double, triple handling. So when we set up the processes for them, what we did was we said, okay, we're going to build a box at a time, which is very unnerving for a lot of people. So when you build stuff ahead, you think you're getting ahead, but really all you're doing is creating more work in the end. So as much as possible, we like to eliminate building ahead. So they build a box, they packed it, they closed the box, and they loaded it onto a truck. The other thing, once we do the process flow, we're going to go into each of the processes and document the work on what we call a standard operation worksheet. And this standard operation worksheet is a document where we document the work that needs to be done. We identify the quality checks that need to be done and any check that I need to do before I pass it on to the next person. So this is the work I got to do. This is how long it takes me to do the work. Again, fair and reasonable time. We don't want the employees to rush. We want them to be able to do this task 8, 9, 10 hours a day at a comfortable pace. We don't want them to rush, because when they rush, they throw quality out the door. The other reason for this document is so we can standardize the process. One of the key principles of lean is standardization and consistency. We want to be able to standardize a process where it doesn't matter who's doing the work, they're all doing it based on the way it's been documented. So again, standardization is extremely critical. Working at a good pace is extremely critical, because quality is first and foremost. It trumps the productivity. So it's not, when we take the times and we're looking at how long does it take to do the work, it's not how fast can you do it, but how long does it take you to do the work is really what we're after. So in a lot of companies, I'm assuming those that are present here today, you have the same issue. Not everybody reads English or understands it. So what we'd like to do is minimize as much text. We need to get this so we can get the times, but when we communicate the work to the employees, let's use pictures, let's use diagrams as much as we can, so it's easier to communicate to the employees. This leaf is not good, we have to trim it. this is okay. So again, anything that you can display with pictures or drawings is the best way to do it and minimize as much text as possible. So now once we collect the data, there are three basic calculations that we're going to do. The first calculation is what we call a takt time. Takt time is a German word that means beat or rhythm. So what we do with takt time is determine how many hours, how many minutes, how many seconds do we want to work per day, and then what are my customer requirements. Now, my requirements I'm looking at are not what I'm doing this year or even what I'm doing next year. My requirements are future requirements, maybe 2 years out, 3 years out, as many as 5 years out, because when we design the process for lean, we don't want to design it for the current volume. We want to design it for the future, so we don't have to go back every year, every 2 years to redesign the process. So takt time is what we call the beat, the rhythm, the pulse rate of the line. It tells us how frequently we need to produce a product off of the end of that line. So we identify that heartbeat, the pulse, the rate, the target. And then the next calculation that we do is what we call a standard waited time. So we take the times of the products. Every product has a different time potentially. Every product has different volumes. So instead of just taking an average of the times, what we're going to do is we're going to take a weighted time. And based on this weighted time, it takes into account not just how long it takes to do the work, but it's weighted more towards a higher volume product. So now my takt time says, this is the rate I need to produce at. My weighted time says, this is how long it takes to do the work. So now when I have those two variables, I can then calculate how many people, how many machines I need. And based on that, now I can start looking at designing my process. So when I'm looking at my customer requirements, I'm going to take a look at what my peak is. As an example, most growers that do a lot of spring shipping, they typically have week 14 to about week 22 where they do 60, 70, in some cases even higher, greater percentage of sales for the year. So we need to make sure that when we design the process, that we design it where we have enough volume to cover the peak. And then what we do is, okay, this is a peak for this year. Let's project it out 2 years, 3 years, 4 years, 5 years. And that's where we want to be when we design our process, whether it's for shipping or for production. If it's for production, your production peak is probably going to be in front of this curve. So again, you guys know what your peaks are. You know when your peaks occur. And then if you have other peaks, fall peak, maybe a Christmas peak or whatever, we want to take those into account as well, because your product mix is going to be different. So we want to make sure that whatever process we design can handle the mix of the different peaks that we have during the throughout the year. So again, progressive work is one of the things that we do that we implement to improve the productivity. And again, progressive work goes back to the Henry Ford assembly line, where he had multiple stations doing different things, different jobs, different tasks on that car. He didn't have 1 or 2 people building the entire car. So this is what we call progressive work and assembly line type work. So if you think of some of the processes you have, think about sticking. Normally when you're sticking a tray, let's say a 72 cell tray, what most companies will do is 1 person, 1 tray, they do the whole thing. Where we look at it slightly different. So instead of having 1 person do 1 tray, we have multiple people do it. Typically 3 seems to be a good number of people working on that tray. So if you take a look at this picture here, the first person, this gentleman here, what he is doing is prepping the tray and then passes it down to the first lady on the line, and she's sticking 24 cells, 24 cuttings, passes it on to the next one. She does 24, and then the last one here does the remaining 24. So these people are what we call value added people. They're doing value added work. We want them to continue to do as much value added work throughout the day as possible. We have another person here, the lady with the pink and white striped shirt. She is a non-value added person, but she's a very important person because her job, her role is as a non-value added person, a non-value added material handler. Her goal is to make sure that she continues to supply them with the cuttings and also with the trays, so they don't have to stop and go get material. So as long as she continues to supply them with their material, the folks working on the line will do more minutes, more seconds, more hours of value-added work throughout the day, increasing the productivity, increasing the output of the line. And if you take a look at this line, very inexpensive. Again, we're not into buying a new equipment or fancy equipment. It's whatever we have is what we're going to try to use. They had the skate wheel conveyor that worked really well, and this is what they use. This particular company has 3 different facilities out in the Northwest in the U.S. In the first year, they do a lot of sticking, a lot of propagation. They saved over $500,000 in labor just by going to this progressive technique. Their investment was extremely small because, again, they're using the equipment that they had. Here's an example of one of our customers in Michigan, and they're doing progressive sticking. So I'll let you see the video. But one of the key things in this video, if you notice, is the rate of the speed that they're working at. They're not working fast. We don't want them to work fast. Nice, comfortable pace. They do a third, they pass it on to the next person. Do a third of the tray, pass it on to the next person. Nice, steady pace. And if you notice, we have anti-fatigue floor mats to make their job more comfortable since they're going to be standing up all day. Again, just look at the pace. These are value-added people doing the sticking. You're going to see the lady step in shortly, and she is what we call the material handler, that non-value-added person that's doing that's making sure that they don't run out of cuttings. In this particular line, they already had the conveyors, they had a flat filler, so they get the trays that are full from the top, and then once they're stuck, they just slide them down their line. Again, nice, comfortable, steady pace. And even at the rate that they're working at now, they are producing 25% more than when they were working on the entire tray themselves. Again, it's kind of counterintuitive where we have more people touching a tray, where it's typically the fewer touches, the better. There's a couple of exceptions here and also one in shipping that I'll explain to you. So the lady in the blue jacket coming in, she is a material handler, and what she is doing is replenishing or getting the next set of cutting for the employees to stick. Again, very little downtime. When they go from one variety to the other, the line should not stop. It should be what we would call a transparent changeover, transparent transition, where you're not going to see the line stop and everybody have to stop on the line. Again, very efficient, 25% greater than what they were doing before. Here's another example in the shipping process. Again, that person does a third of the tray, the shuttle tray. The next person puts in the other 4 plants. Goes down the line again. All they have to purchase was that roller conveyor, 2 sections of a 10-foot roller conveyor, very inexpensive. Go down the line, they pack it, making 1 box at a time. Very clean process, very balanced process. Before, they used to pre-build the boxes, and it would take up a lot more space. Again, simple techniques like this is where you can start to look at it in your facility and say, hey, if I use something like this, it's not hard to do. Can I get the benefit from it? And if you noticed in those example videos I showed you, and even the photo, there were no powered conveyors. If some of you have ever watched the I Love Lucy show when she was in a chocolate factory with Ethel, and they were working on at the chocolate factory on a Belle conveyor, they were always in a rush. And when you put people to work on a Belle conveyor, what happens is one of 2 things. They can't keep up. So what they do is they have to rush to work. So when they rush to work, what happens is they forget about quality. So the Conveyor doesn't promote, belt conveyors or paste machines do not promote quality. And it may seem odd to some people, but having people work on a belt conveyor actually reduces your productivity, because now what happens is you have one person working on a belt, you can adjust the rate of the belt, the speed of the belt to that person. But as soon as you put a second person in there, who do you put the, how do you adjust the speed to the fastest, the slowest person, to the average? So it becomes very difficult to balance. So whenever we design a process, we will pretty much never design it where we have a paste conveyor. There are very few examples where we would have a person work on a belt, and that would be where I only have one pot, one plant, is the only way that we would put a belt conveyor in the process. So again, we try to minimize working on a belt, because belt conveyors are not workstations. So and every time a belt conveyor stops, everybody on the line stops, unlike if you have a roller conveyor. So again, those are a couple of the examples of what you can do as progressive work in a non-shipping environment. I'll show you what we can do in a shipping environment. So now when we work with shipping, what we want to do is take advantage of what we call master pulling. So what we'll do is we'll take a look at the nursery, we'll take a look at the greenhouse and say, okay, how can we split up the nursery? How can we split up the greenhouse? Most growers already have zones or sections, bays that they've got numbered. So what we'll do is we'll work with the company and kind of redefine them a little bit, adjust them if necessary. And what we want to do is we want to create these zones so we can have what we call zone pullers. And what zone pullers are people that are going to be working primarily in a zone. Not all the time, because if we got nothing to pull from that zone today, they are going to go and work in another zone. The advantage of zone pulling is that now, instead of having the pullers pulling product that is going to get shipped, go through the entire nursery or greenhouse pulling product, they are assigned to a zone. The advantage there is that they start to get very familiar with the products in their zone. So now when they go pull the product, they're only going to a certain defined area, as opposed to having to go through the entire nursery. Since they're only going to a certain defined area within their zone, they get to know their products well. They know which plants are ready and which plants need another day or two or a week before they can start pulling them. So now what we do is we improve our efficiencies, because they know exactly where to go, so I can pull it quicker. The other advantage too is by having zone pullers dedicated to a primary, again, not dedicated all the time to that one zone, but as their primary zone, as they're pulling product, they can start consolidating the product. All too often what happens is when you have crews of pullers going through the entire nursery, what happens is they'll go, and as they're pulling, they'll just leave voids of pockets of product that they pulled, and then someone's got to go back later and organize it, because there's no one really assigned to them. So there's a lot of advantages to the zone pulling. Now the zone pullers, just like the people that we're sticking, we want them to pull more minutes, more seconds, more hours of the day. So by having the zone pullers dedicated to pulling, we will then have non-value-added people, which are the drivers. And what they're going to do is they're going to drop empty wagons or racks off at the zones, and they're going to bring back full ones to the shipping area. So the non-value-added person is going to be the driver, and they just go back and forth. One of the common things that we see quite a bit in facilities is that you have a crew of people, one driver, maybe 2 or 3 pullers that are on a wagon going to go get the product, and they drive back, all 3 or 4 of them, back to the loading dock. And what happens there is the driver is a non-value-added person, so they're just adding cost to the product. Now when you add 2 or 3 helpers that are pulling on that wagon as it's doing non-value-added work, we just increase the cost of the product. So the goal is, let's keep the pullers pulling, let's keep the drivers driving, have them drop off empties in the field and bring back full ones to the loading dock. When they bring them back, using our supermarket concept, what we want them to do is put it in a location that we call a supermarket. and we identify the supermarket in this example in a sequence 1 through 50. So typically what we'll do is we'll have 2 master pulls in a day. The master pulls, one's in the morning, one's in the afternoon. We pull the product in the morning and we put it in the sequence that we show here, 1 through 50 as an example. How many racks do we have in the supermarket? It all depends on how many products or how many trucks you're shipping in a day, and we calculate how much space you're going to need. So in the morning, once they fill up the supermarket, in the afternoon, they'll start shopping it. And as they're shopping this part of the supermarket, the afternoon pullers are filling up pull number 2. So when you go home at the end of the day, this pull is empty. They just roll the one from behind up. And then in the morning, they'll start shopping right away. They'll start pulling again. And what happens is the supermarket stays wet. So as they shop the supermarket, you can shop it a couple of different ways. One person can shop the entire supermarket, or we can split it up, kind of like with the progressive staking. We can split up the work and everybody is assigned a certain set of racks to pull from the supermarket. After it's pulled, it goes to the load staging area, to a packing line, whatever the next process is downstream. What they pull is based on what we call a master pull. Now, this master pull here is a example of one that we create from our software, Rio, and it tells you the item, the location, the description, the size, the height ID, because we need to know the height when we're calculating how many racks we're going to need, the quantity that you're going to ship, and then how many racks. And then this rack sequence 1 through 5 is what tells us where to put it into the in the supermarket. Now, this is an example of one of our customers in Alabama where they set up their supermarket, but they set it up based on item numbers. So they'll have the 1,000 aisle, the 2,000 aisle, the 3,000 aisle. So the employees know where to go and shop their product. Now, the way they know where to go and shop their product or what to put on the rack is based on what we call a rack sheet. Again, another example of a rack sheet, or an example of a rack sheet from our software, Rio. And it says, this is load Ohio, for example, load sequence 1 of 17. It says there's 17 racks on this truck. This is a store that it's going to, the type of racks that you're using. This is an order that takes 3 racks, and this rack has 3 shelves. So this is the first rack of 3. And it says, okay, on the base, put this item, this barbecue rosemary, and you got a rack 22 from the supermarket to go pull it. Then on shelf number 2, you get a rack number 12, and shelf number 3, you pull the rest of the product from rack number 5 in the supermarket. So what the rack sheet does is it eliminates the need for the employees to have to use their experience to figure out, okay, how do I put this order together? So the rack sheet basically tells you this is the answer to the puzzle. Go take this rack, go set up your shelves based on the heights, and go fill up your racks based on what the rack sheet says. So I do the master pull, that's the pulling of the product. I do the shopping using the rack sheet, and then once, and this is a rack sticker as an example, and then once I'm done, what I then do is I take those racks, they're going to get QC'd or they're going to get shrink wrapped. And the reason for the rack sheet is it's critical because instead of having the employee try to figure out how to put the puzzle together, the rack sheet basically gives them the answer to that puzzle. So typical savings that we see in lean, productivity improvements range from 20 to 40%. Floor space savings. We did an implementation down in Costa Rica where we got 4 times the volume in the same floor space for a packing house. Reduced shrink. Some of our customers will get their payback just on reduced credits and claims, like using a rack sheet, so that way they know exactly what to pick. So when the product is shipped to the customer, they have that rack sheet on there, and the customer can use that as a receiving document. We work with growers. We're not growers. We don't know how to grow, but we work with growers to kind of help determine what's the best place to grow the product so we can increase the number of turns in a house. One of the key things in lean is that when springtime comes, for example, in shipping, it becomes very chaotic for a lot of companies. And what we want to do is with this process, We want to have a controlled environment, no more chaos, easier to manage. So whether you're a large grower or a small grower, the percentage-wise, the savings are the same. Dollar-wise, obviously, they're going to be different, but again, you can implement it and expect to see the same percentage savings. The same thing that we do out on the floor, we do in the office. So in the office, document your process. What's the product in your office? It's an invoice, accounts payable, accounts receivable, a sales order. So we take the same steps to implement a lean in the office as we do out on the floor. And what I would like to do is show you a video of the from Van Belle. Stop sharing here for a second. If you want to take some questions now, Janine, while I
While you
get
pull that up, I was just thinking to mention that we did have an interview with Dave Van Belle. So that will be a separate webinar where we've got a couple of different nursery case studies that we'll demonstrate. So look forward to that. It's not a live presentation, but we have a recording and we'll be setting that up before the end of the month. So yeah, if there are questions, if you feel free to put them in the chat, or you can raise a hand, or you can put them in the Q&A. I think we're pretty flexible. Maybe to get things started, Gary, I just wonder, before a farm even calls you or thinks about this, what should they do? What's the homework?
I guess the thing is to identify what are the issues that they have. Is it typically it's labor, and how are they addressing the labor issues? Sometimes they address the labor issues by going to automation, and automation is not always the answer, because again, you're spending a lot of money on equipment that you're only going to use a few months out of the year. So identify what their issues are, and then typically lean is the answer to a lot of the issues that the growers have. And the way it normally occurs is the growers will call us and say, hey, we want you to come out and take a look at what we're doing here, see if we can apply lean to help us improve our productivity, reduce our labor costs, and that's typically the way we get started with a customer. We'll go out for a couple of days, review their process, and then take a look at what they're doing, make recommendations for lean, what they can do in their different. Let me try to find that in their different. In the different areas, and identify how they can do it, give them a general idea of what what we call a conceptual design of what the process should look like, how it should run, and what the benefit savings are. Because what we'll do is we'll identify how much labor you're spending today and what is the benefits that they should be able to achieve percentage wise, and then that gets converted into a dollar savings. What I'd like to do is kind of show you a video from the Van Belle Nursery. It's pretty impressive.
First thing, when we have these racks coming, they have this envelope on it. So we scan this barcode and tells us which position it needs to go to the supermarket. Example, this one, when we scan it, shows us, okay, this part needs to go into B1. This is the location. The sticker's other side goes to B1. So after that, we have a computer system this side. It tells us these plants are in the supermarket. You can start picking, shopping, I mean. So when we have, right now, all the shopping list has gone out, but when something new comes in, then it will show us here. Then we print the tags and those goes into this envelope. I will show you the example how that works. This is the one right here. So computer print us this and plus this sheet as well. This is the location of the supermarket. So now the shopper knows where he needs to go to pick the plants. So next step is we put those envelopes onto the racks and align them up here according to our priority, what needs to shop first. And then the shoppers comes here. They check that they need to go into C15, C9, C7, A6. So they start from that end. The supermarket start from there, A, B, C, D, E, F. So now I know I need to go to A6, pick 10 plants, C7, 10 plants, C9, 10 plants, C15, 60 plants. So when the shopper is done shopping, then he brought the racks. He can exist from here. There are other more pathways. He can exist where it's nearby. So then they park finish rack onto these positions. Example, this has been shopped already. Yeah. So now another step, the packers. So packers will take this rack to the packing table. And then they have pallet card in there and the labels as well. So they take the labels out, put the pallet card onto the other rack. Example, this needs to go to 2-shelf wood rack. So they bring the 2-shelf wood rack right there. And now they match these tags according to their variety. This numbers tells them which numbers they need to go. I cannot see the tag right now. Right here. So right there. So they match these tags with these numbers and they just tag it. There you go. Then they put onto the rack that will go to the position. So that's it, that's their work. Now our stager, he will come here. Then he has another scanner. He will scan this barcode. So that will tell us, okay, this rack is ready to go into the truck. Now he will take this rack and bring into the lines here. So he take that rack, walk all the way down where we start that load number. Example, this when it's stacked already to the positions. This is position 6, 4, we have numbers on the ground. So he put all the racks according to these numbers. And then when the truck comes, then we tell the drivers, okay, he needs to park into the dock number 5 for 8098 load. So then the loader truck, he doesn't need to do anything. He just start from that end. And this is actually according to the truck. So that side will go first in the truck. Then he just finish all the way down.
Again, they're a very good example of a, of a supermarket concept. It took Dave Van Belle about 13 years to be convinced that that's the way to go. The grower's biggest heartache is where they have to take the product off the rack and tag it, label it, or clean it, and then put it back on another rack. And that's what we call an extra touch, and that's where a lot of people get nervous. Again, since we look at the holistic approach, we're not just looking at one part of the process, we're looking at it from beginning to end, and that extra touch is negated by all the other efficiencies that are picked up upstream and downstream from the entire process. So once he finally implemented it, I think it was about 3 years ago, when I was up there with him designing it and they ran it, his comment was, I should have done this a lot sooner, because he's been able to ship more trucks out, working fewer hours and being more productive. So Van Belle, again, you're going to hear from him later, and he is a very great example of a company that's taken lean and really run with it, embraced it, and they've done a lot of other things that complement the lean concept that they've implemented.
Gary, we have a question from Kevin in the Q&A.
Okay.
What have been your biggest challenges with implementation? Change management is always difficult, but so if you can give an idea of what your biggest obstacle has been.
Our biggest obstacle is people. Because lean is based on math, a widget's a widget. It doesn't really care. The math doesn't really care. The biggest issues that we have in any implementation is getting the people to buy in. So we go through when we do a 2-day training, typically with our customers. So that kind of builds a foundation. Then we go through with the implementation and we do more training, more education. Our goal is what we want to teach you how to fish. We're not going to give you the fish, but because a lot of people are resistant to change, it becomes very difficult. And the more resistance that we have to change, the more difficult it becomes to implement, and the less likelihood that they're going to achieve a lot of benefits. So we always ask ourselves, what's the difference between a successful implementation and one that wasn't successful? The products are pretty much identical. The processes are identical. The difference is the people. Companies like Van Belle, Jolly Farmer, as an example, they are so committed to it that they're going to make it work. They get their people on the floor involved. So the biggest challenge is people. So we try to work with them as much as possible. Sometimes the biggest naysayers or doubters become the biggest champions in the end once they say, hey, this thing really works. But I would say the biggest thing is getting people to say, hey, let's go with this. I know it's going to work. I'm not big into change, but we need to change. So people is the answer. That is our biggest challenge. And if we have customer or management commitment from the top down, that works. If we try to do like a grassroots effort where the lower level managers or even the people on the floor want to do this, it becomes very difficult, because if the owners, managers don't buy in, it's going to be a tough challenge to implement.
Okay. Did you want to just put your last slide of your presentation back up? It had your contact information on it, or maybe we can put it in the chat, but I know we're at 1 o'clock. I do want to thank everyone. If you want to stay on for a few more minutes, you're welcome to if you have more questions, but I do want to thank everyone during this busy spring for joining us and for connecting with us today. Yep, you had it there for a second.
Yeah.
Presentation. And please join us again for, we have one more live presentation next week. And thank you, Gary. That's great. There's Gary's contact information. So, and then we'll have a lot more recorded ones. I do have a website coming up with our team, LOLA-nursery.com. It's behind me there. I don't know if you can see that, but we're getting it launched in the next couple of weeks, and you'll be so busy you won't care. but by the time June comes, we'll tap you again and see if there's anything we can help you with. But
Again, if
in the
you have-
meantime, I want to say thank you so much to Gary for donating your time and sharing your insights and some examples. And it's a great segue into Dave's some of our case studies as well.
Again, feel free if you want to reach out to me, voicemail, or give me a call, shoot me an email. I'll be more than glad to answer any questions you have. And good
Okay.
luck this spring. Hopefully it's a good one.